With the energy transition comes an increased demand for clean energy. Hydro-Québec must double its energy generation by 2050, making electricity transmission an important issue.
Les Québécois demandent de plus en plus que les lignes soient enfouies, mais l'enfouissement n'est pas aussi simple qu'il n'y paraît.
Quebec covers a vast territory, and its electricity generation facilities are located up north, far from the major load centers in the south. That's what prompted Hydro-Québec to innovate in terms of electricity transmission. We developed a reliable and sustainable power system that called for the invention of the 735,000-volt line. The electricity generated in our facilities is sent at a very high voltage via transmission lines to substations. From there, the electricity flows into the distribution lines and then on to our customers' homes, schools, and businesses.
Les lignes de transport sont moins affectées par les intempéries que le réseau de distribution. Quand vous avez une panne d'électricité chez vous, c'est souvent sur le réseau de distribution. Les lignes de transport, comme on voit derrière moi, ils ont des larges emprises, les arbres sont loin, ça prend des très grands événements climatiques pour les affecter.
On an overhead line, the conductor is bare, and the heat released by the transmission of electricity is quickly dissipated into the air. But an underground line must be insulated and protected from environmental factors like moisture, freeze-thaw cycles, roots, and soil movement. It is essential to have a thick protective sheath. A duct bank, usually made of concrete, may be needed to secure the equipment, significantly increasing the cost. And heat doesn't dissipate as easily underground. In fact, it can build up quickly. Left unchecked, it can cause the cable to overheat, leading to anomalies, cable deterioration, and outages. What's more, underground lines generally need to be replaced every 40 to 60 years. In comparison, overhead lines have a useful life of almost 100 years, and that also impacts the cost. In addition, all the layers added around the underground cable prevent the magnetic field from dissipating. This field opposes the back and forth movement of the electrons. That's the reactive effect, called reactive power. In other words, the total power is made up of two components: active power, which is used to operate our appliances, and reactive power, which must be limited to ensure the stability of the power system. Underground, everything that surrounds the cable traps the magnetic field, which then increasingly opposes the flow of electricity during transmission and overloads the power system.
Si on essayait d'enfouir une ligne à 735 000 volts, ça nous prendrait des postes intermédiaires à tous les 5-6 km. En aérien, on est aux 200-300 km. Donc, ce serait beaucoup de postes. Ce serait des coûts très grands, mais ce serait tellement difficile d'enfouir les lignes que le câble n'est même pas disponible sur le marché.
Undergrounding transmission lines isn't common practice anywhere in the world. Even at lower voltages like 315,000, 120,000, or even 49,000 volts, undergrounding is complex and costly. And that's why it's never the norm, no matter the voltage. Underground lines can increase project costs by 4 to 10 times, and that can lead to higher electricity rates for all of us.